Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at some equations and try to determine whether they are a function of x or not. So in the first one we've got y equals 2x minus 3. For any value that I pick for x, I would multiply that by 2, which gives me only one result, and then that one result I would then subtract 3 from that. Again, that's only one result. So whatever number I start with for x, I'm going to get one answer each time. That means that this is a function. The domain for this function is the set of all real numbers from negative infinity to infinity, because we can plug in any real number for x and multiply it by 2 and subtract 3. The range also is the set of all real numbers, because we can get any number out of there. So we can pick any value of y that we want, and we can solve for x to find the x value that goes with it. So we can show that any real number is in the range of y. For the second one, this is not a function, and the strategy here is to try to find one value of x that's associated with more than one value of y. So for instance, suppose we start with y equals, and I'm just going to pick a number. I'm going to try y equals 10. If I plug in 10 for y, I've got the absolute value of 10 minus 3 for x, which is the absolute value of 7, or 7. So that's an ordered pair, 7, 10. Is there another value of y that goes with x being 7? Well, as it turns out, if we let y be -4, then x would be the absolute value of -7, which is also 7. So that's the point 7, -4. Really, what I could do here is I could pick the value of the value of x that I want to work with, and I can solve that absolute value equation. I could start with, let's say my target was 7 for x. Absolute value of y minus 3 equals 7, and that means we know that y minus 3 equals 7, or y minus 3 equals -7 from the last chapter, and then we could solve for y, but we could see that we're going to get two solutions here. That's why this is not a function. When y is in the absolute value. When x is in the absolute value, then it is a function, but that's not what we had here. For C, this is also not a function. Here we've got an inequality. And if I pick a value of x, let's say x is going to be 1. When x equals 1, we want to find solutions that make this true. So when x is 1, 5x is 5. Any value of y that's greater than or equal to 5 is a solution. So if y equals 5, y equals 6, y equals 7.2, list whatever you want. All of those are solutions because all of those values of y are greater than or equal to 5 times 1. So here, this would not be a function. By the way, I'm supposed to talk about domain and range, and I didn't do that in part B, so I'll go back up there and do that in a moment. But for part C, the domain is the set of all real numbers, and so is the range. And the reason for that, again, we can plug in any value for x, and so the domain has to be the set of all real numbers. And then if you think about what kind of value you want to get out for y, we can find any value of y that would make this true at the same time. Heading back to part B, I didn't talk about the domain and range here, but we know that the lowest an absolute value can equal is 0, and then it goes up from there. So the domain set of all x values that result from that absolute value, that's bracket 0, infinity. The range, though, is the set of all real numbers, because we can plug in any number we want and subtract 3 from it, and from that result we can find the absolute value. So we can plug in any number for y, but the only x values that we're going to get out from this equation are from 0 and above. All right, back to problem D, y equals the square root of x minus 4. This is a function because when you plug in a number for x, you're going to subtract 4 from it and get a unique result, and then you're going to take the principal square root of it and you're going to get a single number. So there are no problems with x being associated with two y's. For the domain, what we know is that the radicand, what's inside that square root, in order to produce a real number, that has to be greater than or equal to 0. So that means that x has to be greater than or equal to 4. And in interval notation, that's 4 comma infinity with a square bracket on the 4. For the range, the lowest that this function can give us is 0. When x is 4, we would get the square root of 0 or 0. Everything else is bigger than that. So the range, square bracket 0 comma infinity. All right. One last one to talk about. This is a rational equation, meaning that there's an algebraic fraction involved. This one is a function because no matter what value you plug in for x, you can add 6 to that, and then you can divide 3 by that number and get a unique result. There's only one number that we can't plug in here, though, and that's the value that would make the denominator 0. So the domain is where x is not equal to -6. So that's one number we can't plug in. If you put in -6, you get 3 divided by 0. We can't do that. In interval notation, that's -infinity comma -6 parentheses union parentheses -6 comma infinity. That's the way that we list all the real numbers except for -6. As far as the range goes, it's a little early in the course to talk about how we can figure out the range, but we can reason this out. If x plus 6 is positive, then that fraction is going to be positive. And the smaller the denominator gets, the more positive the fraction gets. The bigger the denominator, the smaller it gets. It can get as close to 0 as possible without touching it. And on the other side, it can be any negative value except for 0. So here, all we know is that y cannot be equal to 0. And we write that in the same way, trading out the -6 for 0 in the range. All right, that's the end of that video. I will see you in the next one.